the determinant of a, b, c, d equals -3, calculate the determinant of this right here. It looks like a crazy question, and you don't know where to start. Um, what you can possibly start is actually writing out what the determinant of a, b, c, d matrix is, and that's just AD minus BC with cofactors. That equals -3, right? So this term here actually equals -3. Now, um, this is very messy right here. I'm gonna clear up some of this, and I'm gonna get rid of this -2 up here. I'm gonna do that by doing row 1, right? Plus row 3 is gonna change row 1. What that does basically is it gives us d over here. You get 0, right? 2 plus -2, 0, and then you get 2b up here. Then that means you have c plus 1, -1, 2a, d minus 2, 2, and 2b right there. As you guys already know how to get the determinant using cofactor expansion, I'm not going to go over all of that now, but basically using cofactor expansion, that's just d times the determinant of -1, 2a, 2, 2b. I basically, let me just change colors here. I basically cross out this row, cross out this row, take this number, and put that right there, right? Okay, and so then it switches signs, so we're gonna get -0 times all this, so it just cancels out, right? And then we're gonna add again, and using a different color, I'm gonna use green, we're gonna get something like this. We're gonna cancel out this row, we're gonna keep this number, and we're gonna just get 2b, right, times all of this, right? So c plus 1, -1, d minus 2, and then 2. Now finding the determinant of this is not too bad. The determinant here is going to equal -2b. So d times all this, -2b minus 4a, right? Plus 2b over 2 times c plus 1 minus 1 times d minus 2, and that just turns plus 1. And what do we get here? We get, after expanding all that out, we should get something that looks something like this. So we get 2b times 2c plus 2 plus d minus 2. Cancels, cancels. What do we have now? We have someone's 2b, 4bc plus 2bd, right? And over here we have -2bd minus 4ad. What I'm going to do is we can cross out a couple of things over here. We have -2 plus 2, that's gone. We're left with just -4ad plus 4bc. What I'm going to do is I'm going to take out a -4, and then we get ad minus bc. And in the upper example, we actually defined ad minus bc to equal -3. So it's going to be -4 times -3 is going to give us 12. That's our new determinant. So our determinant, the answer is actually C. Going on to number 13, it says if A is a 3 by 3 matrix, right? We have a 3 by 3 matrix. This is just a random 3 by 3 matrix, right here. Okay, this is the random 3 by 3 matrix, and they're saying, okay, the determinant of this matrix 2 times the inverse of A is equal to -3. One thing we want to note is when we take the inverse of a matrix, let's say we have to take the determinant of the inverse of a matrix, it's actually just 1 over the determinant of the regular matrix. Okay, it's just to note that down, to memorize that. You can try it out with a 2 by 2 matrix. Anyways, continuing on, we're multiplying 2 times a 3 by 3 matrix. In the previous examples, we would multiply when we multiplied a scalar with the determinant, we would just do 2, like if we did k times determinant of A, it would literally just be k times determinant. So you just literally multiply that row by -3. But the problem here is we're multiplying this whole matrix by 2. That means we're multiplying 3 rows, right? 3 columns. And that's 3 rows basically. That means it's 2 cubed times the determinant of A, right? So let's get that straight. Now, let's start solving this. 1 over the determinant times 2 cubed the determinant. That literally just leaves us with 8, right? Let me just write that out properly. That leaves us with -3 over 2 cubed equals A inverse. Now I'm going to take I want to get just A, right? And A is just the 1 over that, so that's just 8 over -3. Okay, that makes sense. Yeah, so now we have that, right? We have that going on. Now, it also says, well, -3, let me just change colors here. Okay, green. -3 is equal to the determinant of 2 times A inverse, right? But it also said it also equals A cubed times B inverse times the transpose, right? This is determinant. One thing I just want to note is when you take a transpose of a determinant, nothing happens, so everything stays the same. And we can literally just cross out transpose because it doesn't change anything. Now this is A, and this is saying A cubed. What does that mean? That means 8 cubed over -3 cubed is equal to -3 times B inverse, right? So I'm gonna bring this over, and we should get +3, right, to the power of 4 over 8 cubed is equal to B inverse. Now we take the 1 over that, like I said previously. What do we get? We get 8 cubed over 3 to the power of 4 is the determinant of B. Which is that is B. 13B is the answer. And yeah, so that's basically an example of manipulating determinants. Just a couple of tricks that might also get you is one thing you really want to note is the factorial 2 cubed. 2 cubed is because we're not just multiplying a row, we're multiplying the whole matrix. That's an important point to make. Other than that, yeah.